Hello everyone, in this video we're going to be solving a geometry puzzle. If you like this video, please comment, like and subscribe and hit the bell button for notifications. You can also consider becoming a member by clicking the join button to support the channel. And without further ado, let's get started. Two circles with radius a and b and a square with side length x are inscribed in a right triangle. Find x in terms of a and b. So this puzzle could be considered a general puzzle because it's not asking for numerical values, but asking for the side length of the square in terms of the radii a and b. Now, this is a Sangaku problem, and this is really nice. I like this puzzle a lot. So here's how we proceed. First of all, let me tell you that the plan is to use similarity. Okay, you know that a lot of times we use the Pythagorean theorem in our puzzles, and in this problem too, you can actually use the Pythagorean theorem, but I'll do it a little differently. Okay, just good for the change. Now, what are we going to do? Of course, that will never change. We'll make some good connections, right? So we're given two circles here. And again, a and b don't really matter here, which one is which, because we're going to find a really nice expression. And in that expression, if you switch a and b, it doesn't matter. Here in this case, I'm going to go with the smaller one. I'm going to use the a for the smaller one and b for the larger one. But again, it doesn't matter which one is which. Okay, cool. So let's go ahead and start by measuring the radius here. So for example, this one is going to give us a. And if I make this connection, it's also going to be a, right? Let's make it a little better, like this maybe. Okay, whatever. You get the idea. And then if I go this way, it's also going to be the radius. So I'm going to call that a as well. Okay, great. So we do get a little square here because we have a right triangle. Cool. And this piece is also a. And the side length for the square is x. So let's go ahead and mark that. Now this gives us, since this is a point on the circle, this piece here is going to be x minus a. And this is going to be, okay, I don't know the height of this triangle, but how about calling that h? Therefore, this piece here is going to be h minus a. And this piece is also h minus a. Why? Because you know that if you draw a tangent from a point outside the circle to the circle, like two tangents, they're going to be the same lengths. Okay, that's a really nice property of circles. And this piece is also going to be x minus a. Cool. Now, this piece is x here. And the radius for the larger circle is b, so let's write that down. Let's make a little bit more connections here. This is b, and one more b here. All right, cool. Now, we got another square here. Obviously, these are right angles, so on and so forth. I didn't mark it, but you get the idea. And then, so let's see what happens here. Since this piece is b and b, we know that the rest of this is going to be x minus b. So this is also going to be x minus b from this point to that point. Okay, cool. And since this is b, I got to call the base something. So let's call that k. How about that? And this piece here is then going to be k minus b. And this one is also going to be k minus b between these 2 points. Okay, cool. So we got everything we need. Now what we're going to do is we're going to use a lot of nice properties of geometry to solve for x, and our answer is going to be in terms of a and b. Yeah, now this looks a little confusing, but don't worry, we're going to simplify it. Okay, so here's how I get started. And again, this doesn't matter, like it doesn't matter which one you pick because of the symmetry, because of the similarity. I should rather say, I'm going to go with the top one, and I'll use that small triangle and kind of compare that to the larger one. Okay, so that's one of the things I'm going to do. The second thing I'm going to do is I'm going to calculate the area of this triangle. So this is what I'm talking about. Let me show you what I'm talking about here. So this triangle is the one that I'm going to evaluate the area for. Okay, cool. How do you find the area of a triangle? Especially if it's a right triangle, as you know, it's actually really nice, right? It's base times height divided by 2. So the base of this triangle is x, the height is h, therefore the area is going to be x times h divided by 2. That's the area of the triangle. But there's more than one way to find the area, of course, right? Now, what is another way using the in circle, right? This is an in circle with radius a. Well, we have the SIR formula, remember? Area is equal to SIR. What does SIR mean? It means S times R. What is S? S is the semi-perimeter. Let me write that down. This is an important area formula. This is semi-perimeter, and R is the, of course, in radius. Okay? R is the in radius. So what is S in this case? Well, we're going to need to find the perimeter and then divide by 2. What's the perimeter of this right triangle? Well, it's h plus x plus the hypotenuse. Okay, cool. Let's write that down. H plus x plus the hypotenuse. What is the hypotenuse? The hypotenuse is h minus a plus x minus a. H minus a plus x minus a. That's kind of like a long expression, but don't worry. As I said earlier, we're going to simplify this. Of course, this is just the perimeter, and I'm supposed to divide by 2 to find the semi-perimeter. This is just the semi-perimeter. Now I got to multiply it by the in radius, which is a, for the smaller triangle. Cool. Okay. Now we can just go ahead and multiply both sides by 2, which is going to simplify, and let's see how we can simplify further. Okay, I got x times h is equal to, now h plus h is going to give me 2h, x plus x is going to give me 2x, and then I have minus a, which is minus 2a. Okay, they all have a 2 in them, so that's kind of nice, and I got to multiply that by a. Cool. Let's do it and see what happens. X times h is equal to, if I distribute the a over this, I get 2ha plus 2xa minus 2a squared. Again, this expression looks confusing. There is like a lot of variables, but remember, our goal is to solve for x. So we're going to focus on that one. Okay, let's not lose focus. And for that purpose, I will subtract 2xa from both sides because my goal is to solve for x. And I'm going to isolate x terms on the left and factor. So my next step, it would be then taking the x out, and this should give me h minus 2a. And on the right-hand side, I do have an expression. I can definitely take the 2a out. We can do that right now. Let's do it. And then we have h minus a. Nothing cancels out yet, but we're going to be able to do it eventually, okay? So now from here, I was able to solve for x actually, even though it wasn't just in terms of a and b, it was at least in terms of a and h. So our next step would be to associate h and ab so that I can replace h with something so that at the end, my answer is going to give me x in terms of a and b. But things aren't that simple. Yes, we're going to do that, but it'll take some algebraic work. Okay, so just bear with me, stay tuned, and let's finish this up. What's my next step? My next step is to make this nicer, of course, but I got something for x, which is cool. Now, in my next step, I'm going to be using some other relations. Like what? Well, if you remember our original picture, and I was telling you about similarity, right? So how can I use similarity here? Well, if you notice that, for example, I can compare these two triangles, right? They're similar. Why? Angle, angle, angle. Okay, great. So now how do I compare? Corresponding side lengths are proportional. Therefore, I can safely say that the ratio of h to x, which is this whole thing here, is the same as x to k, which is the base. But not only that, since these two triangles are similar, their in radii are also proportional, because you know that every length inside a triangle will also be proportional, right? That's what proportion means. You kind of magnify something, you make it larger that many times, everything is made larger that many times. Cool. So here is my ratios from there. I can safely say that h over x is equal to x over k, and that is equal to a over b. All right, cool. So now using this proportion and using the above expression for x, I should be able to solve this. And again, my goal is to solve for x, find x in terms of a and b. So let's proceed. What am I going to do? Well, if you look at this expression, you get a couple nice things. For example, if you use the first 2 and cross multiply, you get something like hk equals x squared. One thing to notice here is I don't have any k in this expression. I only have h and a. So this expression is actually not very helpful because it's going to introduce an extra variable. I don't want to deal with that. And remember that we didn't use the bottom triangle or the larger one. We didn't use k in our expression, so that's not going to be very helpful. But at least we tried. So what I'd like to do is then to associate the first and the third ratios. What does this give me? Well, this gives me something nice. If you do the cross multiplication, we get hb equals ax. And since I want to be able to replace h with something, I would like to divide both sides by b and write h as ax over b. So this is the key to the kingdom. I'm going to go ahead and replace h with this in this expression and then simplify the result. It kind of sounds simple and it is not too complicated, but it involves some really nice algebra. So let's go ahead and do that. I will substitute h equals ax over b. So let me go ahead and replace h with ax over b here. And I'm coming from here, right? And at the bottom as well, of course, I'm replacing h with ax over b minus 2a. Awesome. Now notice that in this expression, in this equation here, I only have x, a, and b, which means I can hopefully solve for x in terms of a and b. All right? So that's going to be my next step. So this is like a really crucial expression because this should give us what we need. Okay, cool. Now, in order to simplify this expression a little bit better, I would like to multiply the top and the bottom by b. So let's go ahead and do that because, as you know, b does not equal 0. It's one of the in radii, and we can multiply by b safely. Okay, so that's going to give us 2a multiplied by ax minus ab divided by ax minus 2ab. Okay, don't ever simplify this. Don't cross out the ax or the ab. You know, some people do that, but that's not right. Well, in some cases you can do it, but here you're not supposed to do that. Okay, now what is next? Well, notice that we have a as a common factor, so we can simplify this further, obviously. And we want to do that because it's going to help us. So why don't we just go ahead and pull out an a here. So that should give me x minus b. And then we have another a here, which is x minus 2b. 2b or not to be. We can always make that joke, right? As long as we get 2b. Great. So now we can go ahead and cross out the a here. And next step would be cross multiplication. And finally, we're getting to the bottom of this. If I distribute here, x times x is x squared minus 2bx equals, and then I'm going to distribute the 2a here, obviously. Distributive property, as you know, is super important. 2ax minus 2ab. Now, this is a quadratic equation in x. And again, don't be scared. We can solve it, okay? Because we have an awesome formula, which is called quadratic formula, okay? Right? Or what is called quadratic formula. Now, what am I going to do next? Well, put everything on the same side. But notice that the coefficient of x is going to be the opposite of 2a plus 2b, right? So I can use parentheses to express that way. And then plus 2ab is equal to 0. Well, this doesn't look very factorable to me. So I will use the quadratic formula, which is fine. And it's going to be interesting. You know what? You know what's interesting? We're going to get two solutions. And we have to decide, because we have to go with one, right? Which one is going to be the answer? And that's also going to be an interesting point that I'll be making. Okay, cool. Now, what is the quadratic formula? Negative b, but in this case, of course, negative b. b is the coefficient of x, which is this entire thing here, right? This entire thing with the negative sign, but negative means the opposite, so it's just going to be 2a plus 2b plus minus the square root of b squared. So I need to square 2a plus 2b, and from that I need to subtract 4 times 2ab, which is 8ab. Because a is 1, you know, I'm talking about different a's here, divide by 2. Hopefully you know what I'm talking about. If not, you can look up the quadratic formula and check it out. Okay. Now this expression can be, of course, simplified, and it's going to be real nice when we do, but let's go ahead and expand what's under radical first. Okay, so if you square this, you're going to get 4a squared plus 8ab plus 4b squared minus 8ab. And square root of all that divided by 2. Now notice that the 8ab nicely cancels out, leaving us with something nice. Why? Because notice that you can factor out a 4 here. So you're basically getting 4 times the quantity a squared plus b squared, which can then be written as 2 times the square root of a squared plus b squared. Okay? And all of that is divided by 2. Now we can go ahead and divide everything in the numerator by 2, and we're going to be getting our awesome answer. But not just answer, but answers, because we're going to be getting 2 solutions from here. And here's the critical point. You might be saying, you know what, things are positive, so I want to go with the positive sign. But how can you verify that is the answer? Maybe it's the minus version, right? So we got to verify that. Let's go ahead and split this up into 2 solutions, and then we'll discuss why one of them is a solution and not the other. Okay, so one of the solutions, and you can call that x1 if you want, I won't, is a plus b plus the square root of a squared plus b squared. You know that I'm generally a positive person. I like to write the positive solutions first. Okay. By the way, is the second solution necessarily negative? You can argue that it doesn't have to be, right? Okay. So this is my second solution. Now, which of the solutions is going to be valid, and how do you decide? Here's the critical part. Ready, set, go. Okay. Now, if you look at the first one, I'm not really getting much from that because it's a bunch of terms that are added and they're all positive, and that looks good. So I kind of need to work on the second one because there's a minus sign. There's a chance that it might be negative, or it may not be the solution I'm looking for. How can I check that out? Here's how I can do that. First of all, if you go back to the original picture, and you'll notice that x is the side length of the square, and obviously x is greater than b. You see that? I mean, that's definitely true, because otherwise x minus b would not be a length. It won't be positive. So x is greater than b. And in my picture from the drawing, you can safely say that b is greater than a. If it wasn't, then it would be the other way around. It wouldn't matter. You can always safely say that x is greater than one of them, and that particular one is greater than the other one. So in other words, what am I talking about here? Okay, let me write that down. So let me make it more clear. So I'm basically saying that x is greater than b and b is greater than a. Okay, what is that supposed to mean? Well, it means that if I write this expression slightly differently, look at that. Now this is really cool. I really like this part because it's awesome. So this is going to be, and actually I think I'd like to write the b first. Let me write b first and then write this one. Okay, I believe you can do it either way, but I don't know why I pick it this way. It's just a preference, I guess. Okay, cool. Now, I'd like to separate this quantity. Now, this is what I want you to pay attention to. B is greater than A, obviously, right? Okay, great. Now, look at this expression. The square root of A squared plus B squared and A. Do you think this is a positive quantity or a negative quantity? I say it's negative. My claim is that this quantity is negative. Why? Because A is, or I should say, square root of A squared plus B squared is definitely greater than the square root of A squared, because B squared is positive, and this sum is greater than that sum, or that number. In other words, this is a negative difference. What is that supposed to mean? You're adding a negative quantity to B, therefore you're making it smaller. So this equation implies that x is less than b. Wow, that's interesting. That's actually a contradiction, because we said that x must be greater than b here, right? Therefore, this is false, which means this equation or this solution is not going to work. Therefore, we end up with a single solution, which is the answer. So this is the expression x we're looking for. We were able to solve for x in terms of A and B. And you can test it with numbers. You can draw a triangle, determine the side lengths, determine their in radii, plug it in, and see that it works for any AB values. Well, this brings us to the end of this video. Thank you for watching. I hope you enjoyed the video. Please let me know. Comment, like, and subscribe. And I'll see you tomorrow with another video. Until then, be safe and take care. Bye-bye.